Hi everyone, welcome to Intersect Talks, a series where automotive industry experts cover various topics from ADAS and AD industry trends, to OEM and supplier challenges and solutions, to vehicle software and autonomy best practices. This webinar will cover key trends in vehicle software and autonomy. We'll also share the challenges we've heard from our customers around safety, costs, time to market, and vendor lock-in. Then we'll conclude with an overview of the applied development platform and dive into how our solutions help shorten development cycles, deliver high-quality systems, and accelerate the production of modern vehicles with confidence. These webinars will highlight exciting industry topics and provide an opportunity for discussion. You can expect to learn about real-world insights, practical solutions, and more with various industry guests sharing their experiences and insights. So let's dive in. To introduce myself, my name is Jake Lucier, and I'm a product manager at Applied Intuition. My background is in perception robotics. I was previously in a PhD at Stanford in the AI lab, focused on perception, and then subsequently, I worked on autonomous flight. For the last 5 years, I've been at Applied Intuition, focused on building the next generation of tools to support autonomous systems. Before getting into the industry challenges and themes, I'll share a brief introduction to Applied Intuition. Our mission is to accelerate the world's adoption of safe and intelligent machines. Everything that moves will move autonomously, and the team here is dedicated to helping our customers build the most intelligent systems and bring autonomy to market safely. Our team has cross-domain expertise with deep insights into state-of-the-art technology and emerging best practices. The majority of our team members have highly technical backgrounds, which we utilize to build software solutions for complete vehicle software development for our customers. We have the honor of working with 17 of the top 20 global OEMs, in addition to many top startups in the autonomy space. That's a brief introduction to Applied Intuition. Now on to the industry challenges. Applied Intuition sits uniquely at the intersection of software and automotive, and based on this unique perspective, we want to highlight 3 industry trends. First, consumers expect advanced vehicle software and autonomy. With the emergence of address-to-address systems like Tesla FSD, hands-off, eyes-on systems like GM Super Cruise, hands-off, eyes-off systems for low-speed highway cases, and new automated parking systems, consumers are increasingly growing to expect advanced autonomy. Second, next-generation capabilities require novel technology. These systems that are increasingly hands-off and eyes-off and would be classified as L2+ or L3 systems require product capabilities such as evasive lane changing and traffic light handling. These capabilities often require completely different technical approaches, and consumers are also expecting these technologies to update constantly. Third and lastly, OEMs and suppliers are missing production deadlines. We hear of technical issues caught later in the production process, which push back timelines, impacting bottom lines. So those are some of the high-level challenges. What is it that OEMs and suppliers are really thinking about and caring about as they solve these challenges? Working closely with our customers allows us to understand not only the challenges, but also the consistent themes across the industries. Today, I'll highlight 4 of them. You'll see these themes continue to pop up in our upcoming webinars. The first thing our customers care about is safety. Ultimately, the most important human element of automotive and autonomy businesses is safety. At the end of the day, consumer perception of the safety of autonomous systems is the most important for the industry as a whole to be able to make progress. When we work with customers, they typically think about ensuring safety across a few dimensions. First, customers want to test across their entire ODD. The operational design domain will specify key attributes such as what regions need to be tested, as well as what environmental conditions need to be tested. Second, customers will want to test all of their requirements. The requirements will specify which systems under test to test, such as, is it an emergency braking system? Is it a lane keep assist system? As well as where it needs to be tested, in which test environments. Is it model in the loop? Is it software in the loop? Is it hardware in the loop? Do you need to test perception, planning, and/or controls? Third, customers need to test across the entire geographic region needed. For example, if a customer is developing a nationwide system, they need to test nationwide. And then lastly, customers need to test across all relevant scenario parameterizations.
That includes both nominal cases, for example, going at constant speed with a vehicle at a constant speed leading, as well as edge cases, where a vehicle might be going much faster and there might be much more complicated things going around. We've worked with customers developing systems that range from L2 to L2+, L3, and even L4 highway systems, but all customers need to test across all of these dimensions.
An example of this is when a large OEM customer developed their automated collision avoidance system. The goal of this system is to perform collision avoidance maneuvers to reduce accidents and improve safety. Using our simulation technology, the customer could validate their systems for any complex and dangerous situations that could arise in the real world. The second is lower costs. This is especially top of mind in the current macroeconomic environment where companies across all industries are trying to manage costs.
Our customers usually think about cutting costs in two ways. First, customers can save by simply using simulation at all. This is the trend in the industry known as shifting left. Today, most testing is done on vehicle, aka the right, and customers want to move testing as much as possible into software, aka the left. Where possible, it's best to do model-in-the-loop or software-in-the-loop simulation, which would be fully in software. But where some integration with hardware is required, customers can do testing in hardware-in-the-loop setups, where some hardware is involved, but not the full vehicle and not on road. It's noteworthy that many of the top autonomy programs are moving towards full virtual validation, where the idea is that all testing will be done virtually and field testing will only be a sanity check. Second, customers can then save by using simulation efficiently. It's one thing to use simulation, it's another to be efficient with your data and your compute. So with data, customers can be more efficient by keeping only the most relevant data around in warm storage and moving older data to cold storage. With compute, it's best to use state-of-the-art open source frameworks such as Kubernetes, but it's necessary to add fine-tuned technologies to make sure that jobs are queued up efficiently, executed efficiently, and then results are aggregated efficiently. The end result can save tens of millions or hundreds of millions of dollars for customers.
The third is accelerating time to market. As the industry shifts from building hardware-defined vehicles to building software-defined vehicles, OEMs need to integrate many complex software systems. All it takes is one issue with one system or one system integration, and an over-the-air update could brick a vehicle. So in an attempt to be cautious and avoid these issues, many OEMs are going slow and missing deadlines. Last but not least is the interest in reducing vendor lock-in. Our customers want to build in-house capabilities and not be too reliant on too many suppliers or especially any one supplier. There are two main reasons for this. First, each update to the vehicle would require coordination with many different vendors. And second is brand reputation. If you have more control over the development, you have more control over the consumer experience and the vehicle functionality. Those are the high-level challenges and what matters to OEMs and suppliers. Now we'll conclude by reviewing what Applied has built to support these needs. At a high level, we've built a suite of tools and infrastructure to help our customers address these challenges. Our products help teams develop and validate ADAS systems across the development lifecycle and across a variety of use cases, such as perception and localization, motion planning and controls, log visualization and triage, scenario creation, and more. More specifically, we provide an end-to-end toolchain for the development, testing, and validation of autonomous systems. At the heart of the Applied Development Platform is simulation software used by engineers developing autonomous systems. These tools make AV development cheaper, faster, and safer through simulation. Second is a suite of data products to support development and testing and provide analytical insights to developers and stakeholders. We also provide services to help accelerate deployment of autonomous vehicles. More specifically, the Applied Development Platform consists of a set of tools in both simulation and data. Within simulation, we have different simulators that test different things for different users and use cases. For example, Simian is an object-level simulator used for planning, prediction, and controls, while Spectral is a sensor simulator used for perception.
For log-based testing, we offer a tool called LogStream. This tool allows customers to incorporate log data into any simulation and re-simulate log events. For vehicle dynamics, we offer CarSim as well as TruckSim from the Mechanical Simulation, who've been working on vehicle dynamics for 30 years. And then lastly, when it comes to testing at scale in the cloud, we provide Orbis. This allows customers to run many simulations in parallel and analyze the results immediately.
On the data side, we have tooling to allow users to ingest and analyze all of their data coming in from their fleet, as well as tooling to manage the verification and validation of your system.
For map analysis and editing, we provide Meridian. Meridian is the tool that will allow customers to create maps from scratch, ingest from HD maps, and generally handle any problems related to maps and autonomy. For synthetic data, we offer a tool that will allow customers to quickly generate their own data or use some of the preset data that we make available to our customers. And lastly, we provide applied test suites, which are predefined scenario suites for common use cases such as adaptive cruise control and lane keep assist systems.
So those were the individual tools. Now let's look at how they can all come together in one end-to-end workflow. Here's a diagram that depicts one example end-to-end workflow.
In this diagram, first, we see that Meridian is used to create maps. Users can either ingest real-world mapping data or create maps from scratch. One way or another, though, the output of this step is maps. Second, we see that Strata can then be used to ingest map data as well as drive log data. Strata ingests it, indexes it, and makes it easily searchable by users. Next, we see that then the events of interest are ingested into LogStream for resimulation. This is useful to understand exactly what went wrong and help users iterate quickly. Once there are events that have been resimulated and confirmed to be issues that the team needs to work on further, they're passed along to simulation. This is where we provide a suite of tools, and here we show that Simian can be used for planning and Spectral can be used for perception. Of course, these tools could also be used together for full stack testing. Next up, after the user has then ingested the data, resimulated, and iterated in simulation, the user might then want to simulate at scale in the cloud, and this is where Orbis comes in. Orbis can be used for ad hoc testing as well as continuous integration. And then finally, we have Basis, which ingests data throughout the entire process, provides full traceability, and allows users to understand the performance of their autonomous system. In aggregate, this forms a continuous cycle where developers constantly are getting new issues, improving the system, deploying changes, and collecting more data.
You'll see that a customer can use our tooling to manage all of their safety case definition, from their operational design domain to their requirements to their test cases. That sets the foundation for your development. Then, when you actually need to run the tests, we have different simulators that will test model in the loop, software in the loop, and hardware in the loop. But in addition to those synthetic simulations, we also allow customers to ingest the log data from their fleet. Customers can ingest their data, extract data for perception, as well as for planning and controls. In the end, what we have is a cycle where a customer will constantly define what it is that they're trying to build, test the functionality of their current system, detect any limitations, inform the next stage of data acquisition and development, and then continuously repeat. Okay, so that's a bit about our tools and how they can all come together. Let's briefly just cover some of the key differentiators for these tools. First is scale. It's very important for customers to be able to scale to thousands of concurrent users and hundreds of thousands of simulations daily. Second is having validated models. It's important to not only be able to run simulation, but be able to trust the results of simulation. So it's very important that you have validated models, for example, your sensors and your vehicles. Third is providing an end-to-end tool chain. It's very valuable when you have a cohesive set of tools that support key development areas, such as simulation, data management, machine learning, validation, and more. Fourth, it's important that the tooling constantly evolves. We provide tools at a 5-week cadence, and this allows us to constantly learn and constantly improve our tools for our customers. Fifth, our production tooling is easy to use and has extensive documentation and local language support. And finally, sixth, our platform is extendable and certified, meaning that you can tailor our tools to your use case and always trust them. Okay, now we will answer some questions that we get asked frequently. Okay, so the first question we have here is, if the safety of these autonomous systems is so important, then how is it that we can trust synthetic data for the development and testing of these systems? It's a good question and one that we get asked very frequently. In short, there's a few parts of this. One is that you'll never only use synthetic data. Part of the reason that we provide tooling for managing and processing data is that it's expected that you should also be testing on the road and including some of that data. So it will never just be synthetic data. Now, that being said, we also put a lot of effort in to make sure that the synthetic data that you do use will be as reliable as possible. So for example, when we're talking about sensors, our team has put in a lot of effort to collect data from these sensors in the real world and then constantly use that to validate our sensor models. Our sensor models are physically based, our rendering is physically based rendering, and we make sure that the sensor data that we're getting in simulation very closely mimics what you would see in the real world. Similarly, for agent behaviors, we have collected drive data, and we are fitting our behaviors to that drive data so that over time, our behaviors will get more and more realistic. So in summary, you will not just be using synthetic data, but then also when you do use synthetic data, Applied Intuition has put in a lot of effort to make sure that it mimics what you would see in the real world. Okay, question number 2 here. What are some concrete examples for how a tooling provider can actually help a company save costs? It's a good question. Again, one that we get very often, especially these days. One kind of obvious one in general when talking about simulation is that we help customers move more development and testing from the real world, that is slow, expensive, and dangerous, into virtual environments. So for example, customers can run thousands of tests just on computers rather than having to have a fleet where you have to maintain vehicles, have operators, risk going out into the world every day. So that's one general one, is that by providing virtual development, we can save our customers time and money. More specifically, if we're talking about compute costs, for example, our team over the course of years now has focused on building infrastructure that is highly tuned and can save customers huge amounts of money as they're testing at scale in the cloud. So our tooling doesn't just take open source infrastructure and use it out of the box. We're constantly fine-tuning it to our use case and cutting out expensive operations. Okay, another question here is, can you provide more details on why next generation tooling is required specifically at this time? What are some features of your tooling that are novel compared to legacy previous generation tooling? Another good question. In short, the next generation systems are not simple systems where you're simply staying in your lane and not colliding with any leading objects. Increasingly, as we're talking about hands-off, eyes-off systems, you need to be able to handle many different kinds of situations where you will be in different operational design domains. There will be intersections, there will be lane merges, there will be roundabouts, there will be actors cutting in, there will be pedestrians, we could be in an urban environment. So previous tooling that was very optimized for simulating a vehicle, testing a vehicle, handling simpler situations, just simply doesn't solve that problem. What we provide is tooling that will allow you to model the complexity that you need to model in order to develop these systems. So for example, we not only provide the ability to create an individual scenario, anything in that scenario is parameterized, and you can sweep across all of those scenarios to make sure that you're testing not just one situation, but many situations. That's one example, but in general, our tooling is very optimized for complexity and scale. And another question here, how does your tooling support testing not only individual components, but integrated systems? Another great question. This is something we see very often where the most common problems are not just when you test individual things. It's very often the case that thing A works well, thing B works well. The real problem comes up when you test thing A and B. So the short answer is that our tooling allows you to test many different modules together in simulation. So for example, you can test your perception and your planning and controls in one simulation in order to detect any integration issues that come up. And then increasingly, we're also working with customers, not just on their ADAS modules, but on other software on the vehicle. So for example, how your ADAS system might interact with your HMI, your human-machine interface. So a very common thing for us to do is to work with customers to make sure that we're able to set up a testing environment that will test for any integration that they have. Even though we've had the opportunity to work with some of the top organizations in the world, we believe we're just getting started, and the ADAS and AD space has a lot of room to grow. Thank you for your time today. Feel free to follow us on X and LinkedIn. Please continue to ask questions and stick around. We will have our new webinars posted soon on our online community, as well as our website for you to register. Thanks for tuning in.